So I'm going to tell you the story of the work we do, why we do it, and kind of some anecdotes about a few projects. But I'm going to kind of like just broadly tell you our path, which has been a fun and really interesting ride for us. So as I said, my practice is in Vancouver, Canada. We actually have a small office in Victoria, British Columbia, which is on Vancouver Island, really close to Seattle. It's actually the same distance to Seattle as it is to Vancouver. And we have an office in Spain too, which is very random, but actually really nice. And technically we have an office in Portland, but we don't have any staff in Portland. So that's just a legal thing. But we've had the pleasure of being able to work around the world. So I'm going to show you projects. When I started the firm, I decided that I really only wanted to work in very climate forward kind of practices, and very specifically around using wood. Although not exclusively wood. We work in stone and a few other materials, but for the most part, we're exclusively a wood practice. When we've been asked to work in steel and concrete, to be frank, we turn it down. We don't do that work, and I'm going to explain why when we get into it. So there's a wide variety of stories here. I have a partner, Natalie, in the photo, and Natalie was a student of mine and now is my equal partner in the firm, and there's 50 of us in the firm. And we feel like we've got a really great team. We're really lucky. The work is all over the world. This is actually in California, Oregon, back in California. This is a project in BC, and I'm going to tell you the stories of those projects in a moment, so I won't spend a lot of time now on those. It's really hard and kind of often motherhood when you try to describe what your firm does. And I change the words in this all the time, but there are three different themes, I'd say, that we like to think our practice is about. And what you'll get a sense of is I really think it's important to kind of speak about architecture in the most accessible ways. I don't see this as an esoteric profession, although it involves incredibly complex layers to do it. But I think it's a really accessible art form. And so I believe my role is my team's role is to create healthy, happy, practical design to make the human experience better. It's a really simple statement, but happiness and experience are connected, and good design will solve those things. That's our first kind of job. Our second job, and this is probably the most core value to the way all of our work is connected, is we design for our climate and our environment. And that means something very specific that I'm going to share in a moment. And then innovate for affordability and equity. So those are our kind of firm values. And we are constantly trying to innovate actually in all three of those areas. And hopefully through the work, we're gonna explain it. This is not for you to be quiet. This is how I like to describe our work. I think that as you hear different architects talk about their work, we all have a different philosophy. There's no right and wrong, but I think it's important to know where we come from. And for me, I want my work to be seen as quiet. I want our practice to be seen as quiet. We do not feel a need to be the showy buildings on the block. We actually really want to belong. And that's building good neighborhoods, being a good neighbor. Sometimes it's really appropriate to make gregarious buildings that have a big statement, and we have a few things that are like that sometimes, but for the most part, we're really quite happy to make quiet buildings, and that's about being contextual, right? So how do you fit in your neighborhood? And so I worked for an architect named Cesar Pelli doing some of the biggest buildings in the world when I was a young architect, and he always talked about this, being contextual, really thinking about it. I'm not sure we always did that, but he built Salesforce Tower, and as in here, so you guys know that one. Contextual, I don't know. But nevertheless, this value of being contextual is really important to us. And for me, contextual means an additional layer, which is understanding context of our time. And without question, context of our time relates to this little short version of how I tell this story. 200 years ago, we first started to understand that the greenhouse gases were potentially being trapped to heat the atmosphere. It was 200 years ago we understood, first scientists started understanding that. And 128 years ago, we first started connecting CO2 specifically to that temperature rise and theorized that it was fossil fuels. 128 years ago. 86 years ago, we actually scientists proved that fossil fuels were, in fact, creating the greenhouse gases that would impact our climate. 86 years ago. 49 years ago, my uncle, who was a cellist, a professional cellist, wrote Jimmy Carter. He lives in the States, my uncle, and he wrote him a letter saying, I'm concerned about climate change 49 years ago. 36 years ago, the IPCC, the International Protocol of Climate Change, the Commission for the United Nations, was formed, which happens to be the exact same year I graduated architecture school, 1989. I went to Cornell, and I will tell you there was absolutely zero conversation in my university, and for 2 decades afterwards in the architecture community, this was a very quiet conversation. It didn't come up. Architecture wasn't based on our impact on the climate, but our impact on the climate is profound as an industry, and a lot of people don't know that. 42% of man's greenhouse gas emissions worldwide are related to the built environment, buildings, heating and cooling buildings, as well as the materials they're made out of. 42%. If you wonder where that stacks up, because we all talk about cars all the time, that's the statistic. These numbers don't jump around a little bit from year to year, but 22% globally for transportation. All cars, all trains, all planes together is only 22%. Buildings are the issue, and the built environment, that includes roads and some in that aspect. Now, you can slice climate change into lots of different orders, but this is important because for most people, we talk about cars, we don't talk about buildings, right? And it matters because between now and 2060, we globally need to build, I always speak, as a Canadian, we have to do metric and imperial, so I always have to remember my audience, but 2.48 trillion square feet of new buildings are going to be built between now and 2060. The way we build buildings right now is resulting in a 42% impact on the planet, right? We can't turn that to zero. But when we're going to build this many buildings, if we build the way we are today, we're in real trouble, which means we have to revolutionize the entire industry into thinking about a new way to approach buildings. And we need to do it fast because climate's impacting it. That's the equivalent, by the way, of building one New York City every month for the next 40 years. That's how much building has to be built on the planet to meet human need due to population growth, population migration, which of course is going to get worse because of climate change. So you came to an architecture talk and you're getting a big talk on climate. But it really matters because it's going to inform why I do what I do and how it's the core value in my practice. When you take the 42%, that's the global number. For you in America and for me in Canada, the number is 47% of our climate impact is related to buildings. So it's even higher in the United States, right? And about the same in Canada, if not even higher in Canada, because it's colder and we have to heat our homes more. So you guys are cooling more, we're heating more. So that's breaking down into these two numbers, okay? Globally, 14% is embodied. So that's the carbon in the materials that go into buildings, the embodied carbon. And the other is the operational. So that's the carbon that comes from heating and cooling buildings, which is often from fossil fuels. And so you may be thinking, okay, the big issue is operational carbon. The heating and cooling is a bigger number. We should be tackling that, and we should. But there's a really important concept that says that when you build it's called the time value proposition, but when you build a building, so day one, I've got this carbon footprint from all the materials. And then over time, sorry, I don't have a graph, I'm doing it with my arms. Over time, you're heating and cooling, meaning each year over time, you're adding a bit more carbon footprint to your building, and eventually those two numbers are equal. Your heating and cooling is going to continue, so it's going to get bigger and eventually be a much bigger number than this. Except that distance between the first day you build the building and heating and cooling today is between 15 and 20 years, meaning what you build it out of matters more than how you're heating and cooling it. That's why what buildings are made of matters so much. As we turn to renewable energy, this line actually goes lower, right? Green energy. That means that intersection goes further out into time, meaning what you build a building out of really, really matters when we want to dramatically change our climate footprint. The world is built really largely from these 4 structural materials: concrete, steel, masonry, and wood. There are lots of others, but those are the big 4. And I did do a TED talk that I'm not going to talk about at all. That's the question of what's number 5, because there needs to be the invention of number 5, which I'm convinced is going to come from institutions like Stanford and young minds with real creativity. But these 3 all have a high carbon footprint. In fact, concrete is the largest material we make on Earth after water, and it represents about 6% of our climate impact, and steel about 6% as well, or 5 to 6%. These numbers, again, fluctuate. But together, that's more than cars, right? Just those two materials alone. And so wood is the only material that stores carbon. Okay, so when a tree is growing, it's giving us oxygen. When it is cut down, it stores the carbon, grows, it's giving us oxygen, it's soaking up carbon dioxide. That carbon is stored in the tree. When you cut it down and put it into your dining room table or into a building, you're storing the carbon. You're also offsetting what would otherwise be steel or concrete. So the two things we do to solve climate change are reduce and store. And wood does both those things. But it has to come from sustainably harvested forests, and most of the world's forests are not sustainably harvested. So it's not an easy answer. It's like quite complex, but it can be done. So there's always cool new products out there. And this is a product called cross-laminated timber. Some of you may know about. It's invented in Europe, and it's now made here in North America and throughout the United States. And it's like a jumbo panel. You know, they can be up to 12 feet wide and 64 feet long. Huge chunks of glued together wood. And what that means is we have the ability to design totally new buildings in wood that we never thought we could do before. So these drawings are quite old now. About 20 years ago, I was starting to work on how we're going to build skyscrapers, which seemed crazy at the time. How could we build really big buildings? So this was a proposal for Paris in 2010 that was showing a 35-story wood building, which was a bit of an idea and a fantasy to show that it could happen. But what over time we've been able to do is actually, sorry, I'm going to go back and just let this video go here, if it will. Or not. That's on me. I haven't set up the video properly. Oh yeah. Oh, look at you knowing how to do that. I'm still bad at this stuff. Let's see if this goes. Oh geez, I screwed that up. That was on me. I touched the screen. Get away. Be ubiquitous. All right, don't touch it. Okay, so what we did was we started these exercises, and there's a long story that goes to how we ended up coming up with this idea, but we realized that this new material would allow us to build bigger buildings. And eventually, working with my team of engineers, we were able to actually show that you could have built this building, which we're going to get to in a second, entirely in timber, the Empire State Building, which is crazy to think about, but we fully engineered how you'd be able to do it. It's 107 stories tall, and we could build it in wood. And it'd be safe. And of course, you're gonna have lots of questions, and I'm not gonna go through, will it burn? No, it won't. Will it fall down? No, it won't. The solutions are there. And I'm not gonna tell you all those stories today. Happy to talk afterwards about them. But we've been able to drive this idea from these conceptual ideas, conceptual engineering ideas, into reality. And so I won't go into tons of details, but there are a million ways to do it. It's not one. There are also a whole family of products we can use now that exist. They're all together called mass timber. That one I showed you, cross-laminated timber, is one, but now there's a whole family of these huge panels that allow us to build big buildings. And some of this material is used here already on the Stanford campus. So from that, because I live in a forestry province of Canada, this huge forest, I was able to work with our government to build this building, which is the first tall wood building. It's not very tall. It's in a very small community. They didn't need a big building. But we were able to show this technology in 2010 to build a building entirely made of wood. Even the fire stairs, the elevator core, every part of this building is made in wood, including in this case, and I don't usually do this, the exterior of the building is all wood. And it's called the Wood Innovation Design Center for the University of Northern British Columbia. And we were able to kind of really test our ideas here and push a lot of innovation on how these buildings could be built. And there are layers and layers of stories beyond carbon. But just from a carbon point of view, we did a whole series. We did 2 different life cycle assessments to understand the difference between this building and a normal concrete building built the same way. And we were, in the first version of this, we were 86% less carbon by building this building compared to a traditional concrete building. So now think about 86% less and multiply it by 1 New York City every month for the next 40 years, and you see why this matters, right? If we can change our technology, we can make a difference. I'm going to show you a few minutes a building not far from here where we were able to show that it was 96% less carbon than a building that was built by another architect just down the block, 96% less carbon, just by changing the technology of the way we build. So, the inside looks like this. It's beautiful. It actually has a whole other layer of, benefit, which includes the fact that we know that wood environments are actually healthier for people. They actually are proven to show that people have less stress when surrounded by natural materials in wood. That less stress actually means that children learn more quickly when in a wood environment, that people heal more quickly, and people work more productively. And we don't have great science on this, but we're getting better and better at being able to do the analysis. And in a minute, I'll show you the office building nearby and some of the stats we were able to kind of generate from that. So, so this was our first quote unquote tall wood building. It's 100 feet tall. It's not very high. But it showed that we could do it, and it was very easy to do. And one of the things I loved about it, and there were so many surprising stories to it, was that about 7 blocks away, they were building a Delta hotel out of steel. And the only thing you could hear on our construction site was their construction site, because this is such a quiet way to build. And that matters, right? How many of us have been around construction, have been woken up in the morning, or can't study on campus because there's construction nearby? All of us have had that experience. We don't actually innovate to reduce noise, but now we do. And we need to think that way. All of these impacts, from climate to noise to other kinds of pollution, all are a cost to society, and all can be fixed through innovation, but we need to incentivize those innovations. So I'm going to jump around chronologically. This isn't actually in order at all now, but from that early days project, we've gone on to build many, many more CLT buildings all over the world. And this one happens to be in Paris. We've just finished it. It's a mixed-use residential project in Paris. It's really unusual because it uses curved CLT panels. And in each culture, we're actually using this technology differently. So it's not one technology. It's actually literally almost every building I've done has a slightly new technology to it. And the idea is to propagate, depending on different types of buildings, all new ways to build these buildings. They go up fast. They go up quiet. They produce almost no waste because everything's made in a factory and brought out to the site in a really efficient way. And in the end, we believe they become really beautiful. But what you'll notice is the outside doesn't look like wood. And that's the reality of rain. I don't put a lot of wood outside buildings because it's hard to maintain. And we think about that a lot. And the outside of a building is that weather protection layer. It's there to protect the core, the structure, just like the human body, right? We wear coats to protect our bodies, and buildings need to do the same. And so we don't tend to build wood buildings on the outside. So that exercise, and I'm going to show you again, not chronologically, but has led to some projects of kind of extreme scale. And currently we've just announced this year that we're building, or actually I guess last fall, that we're building a 55-story tall wood building here in America. It's really hard to do. The building codes don't allow it. In certain places they do, in certain places they don't. And this is Milwaukee. Currently, the world's tallest wood building is already built in Milwaukee. Who knew Milwaukee was killing it? But they are. So when I do this lecture and I'm in Europe, I always put up the map of the United States. And then slowly I realized, actually, this is helpful for everybody because they don't know where Milwaukee is. And so that's Milwaukee. We learned geography. I don't know what happened to the rest of the world. That's Milwaukee. So, and the reason I put it up is because right next door by a 1-hour train ride is Chicago. And what's really interesting is a shift that I'm seeing in the world that's kind of fun. And that's that innovation now is no longer the land of New York and Chicago and LA and the big cities. It's actually happening in these second-tier cities that see new opportunities for growth to embrace change. So the mayor of Milwaukee and the fire department of Milwaukee and the whole political system in Milwaukee are like, yeah, bring it on. We'll do it. We'll work with the building codes. Chicago told me they're not going to allow mass timber buildings until their next code change 10 years from now. Right? 10 years from now. So that's, let's see, that's 120 months of New York City's being built before they're even going to change their building code. We don't have time for that. So what we need to do is show by example what's possible in places like Milwaukee and then take that technology all over the world. By the way, that's where Vancouver is, right? So these are really early designs, and I'm going to be honest, I'm not super proud of them because they're not ready for prime time yet. That's not my design. It now will be, so I'm going to change it. It's 35-story building, 35-story building, 30-story building, The middle one's a hotel. The one on the right's an office building. The left is a residential building. And in the back, that's the residential 55-story in the heart of Milwaukee. And it's a cool site, but it's, Milwaukee needs this. It needs revitalization, and they're bringing people back into the city. And so it's really interesting how much they've embraced it. And it's 1.3 million square feet of building. So it's a lot of wood. So here's the answer to this question: why tall, right? So I've been running around talking about we should build these tall wood buildings, and gave a TED talk, and that TED talk I translated into 30 languages and like all over the world. And it's pretty exciting, pretty cool, and it's new technology. And a ton of people said this never happened, and now it's happening, not just with us, but like architects all over the world are now doing this. But the reason why is kind of important to explain. When the first skyscraper was built in the world, it was in Chicago, right? It was 10 stories tall, and it's because Otis had invented the Otis elevator. We had elevators before him, but he proved they were safe in the World's Fair. And because of that, Chicago became the beginning of tall buildings. And one of the things I love to think about is that if you were wealthy before the elevator, you lived on the ground floor. And then the moment the elevator came around, you lived on the top floor. So the city's changed, right? Where we could live because of that change. But that first building at 10 stories, people were terrified to walk underneath the building. It was terrifying, 10 stories, which is kind of hilarious, right? There's an 11-story, 10-story building here on campus, right? It's nothing to us to think about that scale today. And so what I realize is we need to show that we can build these super tall buildings, because what it does is it pushes the engineering, pushes the technology, pushes the building code, but it also says, if they can do this, this is totally fine. And to get the public to get on board with this, the hardest part of my job is reshaping the public's perception of what's possible. And that means stretch their imagination and then do what's probably right, which is not super tall. So what's ironic about it is I don't really like tall buildings at all. I don't really enjoy designing them. I think that when they get really tall, like there's a height I like, but when they get really tall, I think they create social disconnect. I don't think they create great communities. I think people don't know their neighbor on their hallway, and that's not good for society. So there are other reasons to build towers or not build towers, and that's not why not to build towers, in my opinion. But that's not what I'm advocating for, and what I've been trying to do is just stretch imagination, right? So that's a bit of a backstory. And so instead, most of our work, and I'll take you through a bunch of other stuff, some built, some not built, most of our stuff's not big, but it's showing that new building types, almost any building type, can be built with mass timber in this new way, and that it creates beautiful buildings that the public really love and that are really practical and affordable and deal with this climate crisis, or at least help, right? They're not sustainable. They're more sustainable than the alternative, and that's important to know. There is no such thing as a sustainable building, except for the very, very rare exception where somebody digs a hole in the ground. Anything else is going to have an impact. All we can do is get a bit better and make buildings more sustainable. And that's the goal with this. And by the way, I'm not going to talk about it today, but if you want to watch my other TED Talk, I call it 5, it's about that 5th building material. That's because this technology is cool. It's a big new change. It's being embraced. I just came from a conference with 4,000 architects in Portland last week. It's being embraced throughout North America and the world, but it's not a permanent solution. This is a bridge solution. We can't cut down our forests. We have to balance how we do this. A lot of the world's forests are at risk because of forest fire, because of climate change. We have to keep innovating and adapting. And so this, to me, is a bridge technology, and it's an important one, but it has a lifespan. It's not going to be forever. And so I'm going to show buildings now that just give you a sense of like how we're applying it to other types of buildings. This is in Sweden, in northern Sweden. We're building it's got a great name, multi-activity house, which means kind of what it sounds like, multi-activity house. It's above the Arctic Circle, and it's for a community that live in total darkness for a month of the year and then total light for a month of the year. And so this is basically a community center. So it's got a public library, and it's got an art gallery, and it's got theater space, and it's got swimming pool, 3 swimming pools, and it's got a gymnasium and a shooting range and a rock climbing wall and a bowling alley and a series of restaurants, and it's insane. It has the coolest stuff in it. And every time I was like, what about an outdoor ice climbing wall? Because that's my sport. They're like, yeah, let's do it. So they're really positive about it, which I love. So anyway, this is all mass timber. And and pretty excited. And this is actually under construction now in Sweden. And people always note for me, they're like, but Sweden's so good at wood. Why are they hiring a Canadian? I'm like, because you know some stuff. We're not so bad. But there's this global sharing, right? That's what's so great is that everybody's doing it a little differently. We're all learning. It's a fun time to be an architect playing in these materials because, like I said, not everyone's the same. Where each time we're getting better, we're learning more. And I think, we've done an enormous amount of these right now, but we still are constantly innovating and improving. And that's a blast as a designer. So that's the backside with the swimming pool. See the big corkscrew? And there's actually even a cross-country ski circuit around it. They're pretty obsessed. So let's jump to a build project around the corner. You guys can drive by this building. It's for, I think I can say this now, it's for Google. It's a new office building for them in Mass Timber, and it's their first ever Mass Timber building. I'm allowed to talk about certain things with them. Is there any Googlers in the room? Don't get me in trouble. Not allowed to talk about other things. So it's a sweet building, and this was a hugely pleasurable project to work on. Just Google were great to work with, super interested in innovation, allowed us to test a lot of things in their R&D lab. And it's a very unusual building. You get a sneak peek inside. The north side's really quiet. It's like a box, which is fully glazed, but it has this really unusual curtain wall system that's called a closed cavity system. So it's this wide glass, 3 panes of glass, gap, 1 pane of glass. In that gap, there are wood louvers. You can kind of sense in these, we'll go back, you can see those wood louvers. Those open and close. They're about that wide, and they're made out of koya. And they open and close based on the weather station, and we can control the daylight throughout the day because they have a requirement of no glare on your computer screen for the Google workers, and also for a certain amount of daylight for the Google workers, which is really important, right? Germany has a law that says every worker has to have daylight. I mean, Google figured out that's a good law, and they're doing that too. So wherever they can. So I think, so this envelope is really unusual and allowed us to do on the north side, this really quiet building, and then on the south side, a building that has these cantilevers, and that's honestly because Google wanted it to be googly. And it's not as quiet as I'm used to, but we made them happy, hopefully. And I think they are happy. This is a building that was 96% less carbon than another building nearby, and that was built at the same time. So we were really proud with that. And the best line I heard was when Sergey came through the building, the founder of Google, one of the 2 founders of Google. He came through the building and he learned there was 96% less carbon, and he said, "That's really cool. How do we get rid of the last 4%?" And I'm like, that's why you're the founder of Google. That's exactly the right kind of question to ask, right? And it's a great question. It's hard. The last 4% is really hard to get rid of because glass and aluminum all have a big footprint. Aluminum's really high footprint. So couple shots coming up on the inside. It's huge space. There's a big atrium in the middle. That's part of, a bit of a sense. And then that's it during construction. And I might stop in a second here. I'll show you some detail things that are unique. The floor to floors are huge. It's 30 feet in the floors where all the staff work. But I'll just kind of go slow here for a second. So the way wood goes together is completely changed. And so I'm a big wood nerd in how things go together. I'm I have a big wood shop. I build myself a ton of stuff. I'm a pretty good carpenter, a pretty good timber framer. And I love that stuff. I get on site and I annoy them because I'm talking to them all the time. But what you'll see here is you may be used to seeing older wood buildings where they have those steel plates and big bolts on the outside. The weakest part of a wood building, a modern wood building, is the steel. That's what's going to melt in a fire. It's really counterintuitive, but we have steel in these joints between the beams and the columns you're seeing. There's steel in most of those joints, not all, almost all of them. We'll go forward a couple slides. So that one actually is just wood to wood, but a lot of the joints will have steel in them. And we bury the steel inside the wood because the wood is actually the insulator from fire. It's very counterintuitive. So wood of scale, big wood like this, burns really, if there was a fire, burns really predictably, 0.6 millimeters per minute. It's actually really predictable at this scale. And so we know how far it'll burn to protect the steel inside And also we know how much time it would take to burn before it structurally fails. And it's a really long time. And we can calculate that and design for it. So it's actually very easy to make these buildings fire safe. But again, counterintuitively, the weakest part of the building is the steel. So we need to protect it. So you don't see, when you see a building with the steel plates on the outside, you need to call a different engineer. That's not the way you do it anymore. It's not safe. You can see small buildings that way, but big buildings can't be built that way, or shouldn't be. So those are some of the differences. But this is also a difference. See that steel thing? That's for California. So the building code here didn't allow us to where I live is high seismic, and of course high seismic here. And so the vertical load of the building goes through the columns, but the lateral load for earthquakes was required to be steel. So those steel pieces there are because we needed to make it work with the building code, which is heartbreaking because I always want to figure out what way. I'm really bad at following rules, and I wanted to break the code, but California, it's hard to break the code. We will, but not yet. There are also areas that are really unusual. And what's cool about these wood technologies, and I said, it's every time we do it, it's a little bit different. In this case, see these little fins in there, in that gap, it's called the HKS system. Those are fins of metal with little holes in them. And in this case, it's a hybrid system. So we actually pour a thin layer of concrete across the top of it, and it bonds through those little holes. The concrete, it's kind of like rebar, but it actually bonds to the wood. So you get a wood concrete hybrid structure. And why that's really cool is when you deal with a structure, okay, the top in a floor like this, the top is in compression, meaning the top is pushing together, and the bottom of the slab is in tension, meaning it's pulling apart. So in our case, the wood's on the bottom, it's pulling apart. You see it in the ceiling, so it's aesthetically really nice. And the concrete, which is really good in compression and terrible in tension, concrete's in compression. So you're combining the best qualities of the two materials. We have to do this sometimes in order to do bigger spans, or if we're doing a laboratory building for a university, we want to do that to reduce vibration, for instance. So the ability to mix materials still exists in how we're working, but these are all new. And this is the first time this has been done in America. We'd already done it a few times in Canada, so we knew how it worked really well. But each time, these are like innovations that will, I hope, inform and transform the industry. So there you see the steel, the integration of the steel. Now that steel is all painted with an intumescent paint. So it has a fire paint on it. And it's not very thick. It would be a lot thicker if it was carrying the weight of the building, but it's only carrying the lateral, so it didn't need to be as thick. And then you can see sprinklers and things kind of hang out there, or you got to figure out how to integrate them. This is also Google. This one's not finished yet, so they haven't moved into this one. Oh, sorry, that's out of order. But you can drive by. This isn't far away, Mountain View, and that's the entrance. That's big. We're really excited about seeing people move into this one. It's quite a huge project, but it has this big gathering space. That grid shell of the roof is a reciprocal frame, meaning that span, each of those members basically as the weight is on them, they push against each other and create this taut wood structure for how that ceiling works. And so, what I would say is, as I said, like in each case of our buildings, we're trying to look for how can we showcase an innovation? How can we make something really beautiful and perform for its needs, create a long span or whatever it is that we need? But also, how does it teach us something going forward, right? And in this case, there's a whole bunch of lessons we're able to kind of teach the industry here. And actually, we end up often having to develop new products that companies start to carry after. And we've done that a few times on this project. Okay, jumping to a totally different scale. Because not only do we do mass timber, we do light wood frame, right? So light wood frame is a North American technology. 2x4s, 2x6s, the stuff you buy at Home Depot is how most of us live in homes built that way, right? So this is kind of fun because there's an affordability crisis going on. And what we're able to do with this is the Canadian government said, and we were talking about it earlier with some students, is the Canadian government recognizes we have an affordability crisis. So do you. Basically, every country I go to has an affordability crisis. There's nothing new about it in any country. And depending on where you are, certainly here in San Francisco area, certainly true in Vancouver, The way I kind of use the rule of thumb is 1/3 of the cost of a property of a building is in its land. 1/3 is in the construction of the building, and 1/3 is the regulatory process and taxation. So if you want to lower the cost of a project, the fastest thing you can do is change regulation, right? And the process of making buildings takes a long time. So when I showed you the very first project, that first tall wood building that we built in Prince George, from the first day of design to opening the door was 14 months. So if you've been involved in construction, that is unheard of. That is so fast. But we had everybody on the same page. We were able to create momentum, but we were building something that had never been built before, didn't meet the building code. We had to test everything as we were going, and we still did it in 14 months because the government helped pave the way through the regulation for me. I got all the support I needed out of our provincial government. They were incredible. That shows that if we want to solve problems, we have to think beyond just technological solutions within construction and start thinking about revolutionizing the process of building. So, Frank Lloyd Wright's Falling Water, we were talking about this earlier today, was drawn on 11 sheets of paper. Today, an architect would draw that same house probably on 100 sheets of paper, right? Is it a better building? No. The Pentagon, largest office building in the world until recently, 6 million square feet, was built in 14 months. The Empire State Building, built in 14 months, right? Now, if you're building a tower, 8 years, 10 years, that process is what's costing us. And so revolution and regulatory process is really important. And I do think there's going to be really cool AI tools, and we're working on some. Can't talk about those yet, but we are working with a tech company in the area on a solution to this using AI. But in the meantime, what our government said is, let's just create a housing pool of things that any homeowner can download, take their single family residence and turn it into a quadplex or a sixplex on a single family lot anywhere in Canada. And so we're currently still doing this, building this catalog that are pre-approved. So there's no regulation. We take away all of that time. You can download it, give it to a builder, they can go build it tomorrow. That's what we have to do to address the affordability crisis, or one of the many things we have to do, right? There are many, many, many other things, but that's the start that we're working on right now in Canada, and it's really great. I mean, this is a 50-foot wide lot, sixplex. The buildings are very, very inexpensive. They're designed to be very inexpensive. Of course, they can be, more elaborate, but it's been a really cool exercise. There are 4 architects across Canada that have been working on this with us, and it's an interesting solution, right? But that's small. That's also about building up a prefabricated housing market. So you build in a factory and you bring it to the site, and we can do that with that scale houses really easily. Okay, randomly, I don't know why this is next because I kind of just shuffled the deck a bit, but this is a new museum we're working on in British Columbia, the Royal BC Museum, all mass timber. What's really fun about this is when I walk to work, I'll walk right past this building, which is really fun if we get it built. This is at Oregon State University. This is the forestry school at OSU. Oh, sorry, that was so small. This is all timber, a whole series of innovations that we worked on with them to help introduce mass timber into the state of Oregon. And now there's producers in Oregon. I got to work with the governor's team on raising the money for this. It's really fun. Some of this stuff has been weird as an architect that you don't always get a chance to work on, but because we were pushing new industries, we got welcomed into some pretty crazy formula conversations. So Oregon State has been great. Unfortunately, the funny thing about these photos for me, this building opened in COVID. We took these photos in COVID with fake students. And we haven't been back. We need to go back and reshoot with real students. These are like, could you just come and stand here and take your mask off for 2 seconds and then jump back in? So these are all fake student photos. But as I said, students learn faster and people work more quickly. When we started working with one of the local tech companies, one of the first things they said to me was no straight corridors. And I was like, wow, what does that mean? Like, what do you mean by no straight corridors? And it was just so interesting how well they knew their team. And they said, like, we have a lot of people that have social anxiety, and a straight corridor means you see somebody way in the distance, and now you're walking towards them, and that anticipation can cause a lot of stress for people. And I was like, that's really cool that you know your team, and that makes sense. I get that. That'll happen to us if I run into you somewhere here. So in working with them, we wanted to understand stress. We want to understand this. Like, what does this really mean, right? How many people take sick days in a year at these jobs, right, because of stress? Or how much does stress inform what people's general well-being, right, or job performance? And it's really hard to do that. But working with them, we were able to kind of do some case study testing. And we think somewhere between 5% to 10% more sick days happen in environments like not this, because there's nice wood here, but like in the traditional built environment compared to these wood environments. This is good. This is good. It's dark, I couldn't tell. 5 to 10%. So in taking some of the buildings we've been doing with 1,000 people working there, and you take, say, 5% less sick days times some of the salaries, we're talking significant sums of money attached to the simple choice of what you build a building out of, right? Kids learn faster, people heal quicker, people work more effectively and have less sick days. We've got to dig into this. That matters, and we don't have enough data on it, but this is really important stuff because people ask me, does that building cost more? Is wood more expensive? Which is a totally legitimate question. And historically, it was a little more, to do this stuff was a little more than conventional construction because we didn't have an industry that understood it. We didn't have a lot of competitor material manufacturers. We do now. It's come way down. Now I think it's dead equal with steel and concrete. Depends on the marketplace, depends on global steel prices and global wood prices and tariffs and things like that. Sorry. We're just as bad. Everybody is. So, you know, it depends on so many things, but we can make these buildings cost competitive. But let's start actually looking at these other aspects of cost. So another one of my TED Talks is called True Costs, and it's about like, look, society is loaded with impact costs. I talked about sound. We talked about, you know, traffic jams caused by loading trucks and concrete trucks coming back and forth and beeping and all the stuff that we deal with every day that nobody pays for except for all of us, right? The construction site doesn't pay for these choices they make that have direct impact on society. Larger carbon footprint, bigger environmental footprint, noise of construction, longer shutdowns of roads. All these things are a cost offloaded onto the general public. But when we innovate well, and when we charge that to a project, all of a sudden they want to innovate away those problems. And better yet, when you say, look, you can make more money and have less sick days with your staff and actually be more productive or be more healthy or learn faster, where's the value of that, and how does that get added to a construction budget? Are we going to really talk about what things cost, or are we going to pretend it's all assigned to this very archaic way we think about the value of a building, right? And so our goal, and the many different things we're kind of curious about, is how we transform a global conversation about how we even just talk about price of buildings to be more honest about it and to see the value of the things that actually should matter, like performance of a building. And it's hard to do, but it's important. So this project was able to do a lot of that. This is a really weird innovation center where they basically, it's a robotics center. So they fly, they do these, the students do drone battles in this space, which I'd never heard of. See the drones in there? We literally designed a drone battle room because it's so important to the school. Like that, they clearly have too much money, but it was kind of interesting. This is a hotel we're doing in a small island. It's very early drawings, but it's actually, I was telling Zach about this earlier. This is on a site on an island called Salt Spring Island. I live here, and Salt Spring Island is, if you know the San Juan Islands in Washington State, some of you know them. They become what we call in Canada the Gulf Islands. Same islands, just different name. So I can see the US ones from here. And this site is a 4,000 or 5,000-year-old First Nation site, indigenous site. And it's at the end of a bay, and it's and so where we work, and I'll show you in a minute, we work a lot with indigenous community. We have 12 active projects with different nations throughout British Columbia right now, schools and health centers and community centers. But in this case, we basically are working to sort of say, if you just landed here and had nothing, and you had to build a shelter, how would you do it? Well, if you watch, Zach and I were talking about this, you watch these TV shows and you like build a little lean-to and then you cover it with, boughs from the forest. And so we're building this hotel basically with the same technology you would do 1,000 years ago, 2,000 years ago, and building on this site. And these images don't really do a good job showing it, but I'm really excited. Next time I come, if I ever see you guys, or if you want to come visit, come stay here, because it's going to be sweet. This thing's one of my favorite projects. As I said, we do a lot with Indigenous communities. This happens to be housing for the Lakwam Nation, which is way up near Alaska. Through that, we've become really connected with the arts community, the Indigenous arts community, which is super fascinating. And we've been able to incorporate a lot of Indigenous work into our buildings. I learned from working for Caesar a kind of cool thing, which is to think about, which is that so many times there's an art program where an architect will build a building, and after it's done, they'll put art on the wall. Sorry. And that's fine. Like, art programs are really important. It's important to invest in art. But there was this old, if you think about an older building, and some of the buildings we see here on the campus, there is this old tradition where artists were engaged at the beginning of the process, and craftspeople were engaged in the beginning of the process. And the architect and the craftsperson and the builder and the artist all work together to integrate into the architecture of the art, not just add it later. And so when I worked for Caesar, we did Washington, D.C.'s airport, and we did that. We created this big program of art. And if you ever go to Reagan National Airport, you'll see it everywhere, where it's the handrails and the floor patterns are all artists instead of the architect. And it was a really cool experience. And so with our Indigenous community, we're doing a lot of that, where we're not waiting till the end and asking them to contribute. We're saying at the beginning, how do we do this together? What's this process? This is yours. These are your traditions. These are your arts. We don't want to do anything without your input. What do you think? And it's growing. It's a really cool process. And that project is light wood frame, not mass timber, but this is mass timber. So what's my time? Make sure you give me a hook here. Perfect. Okay, so mass timber, I said, it's got all these different applications, right? And one of the coolest things I think about it is that it means that I can prefabricate. I can build in a factory, highly accurate, cutting it on CNC machines. Every hole for every pipe is all done in the factory, arrives. It's really easy to build. Like I said, it's really quiet. It takes a very small team. When we build these huge buildings, you see literally 4 guys on site. 4 guys. It's crazy, and they're really good, and they really love it, and we work to train them. But it's really interesting. New York, the Carpenters Association, totally against it. Ontario, the Carpenters Association built an entire building to teach carpenters how to do this. So it's really interesting, the different cultures there too. In this case, this is on Baffin Island. Anybody know where Baffin Island is? It's a good trivia question, right? It's right next to the island that's going to become America maybe not soon. No. So it's a big island right next to Greenland in Canada. And it's where my dad immigrated from Scotland to. So I was born up here in the Canadian Arctic, way above the tree line, which is incredibly ironic, and in an Inuit community. And so no roads, you got to fly or boat. I was born in a community of 3,000 people, and all Inuit. And so I was asked to come back on Baffin and build a Inuktitut, that's the language, Inuktitut Language Center and Cultural Center. And so in this very remote location, the ice freezes. So you have like certain times of the year, you can basically bring in boats to build anything. There's no building materials. So prefabricating this really cool cultural center is something we're really excited about. We're still fundraising for it, but it'll be the only Inuktitut language center in the world. And my dad, with his thick Scottish accent, learned to speak Inuktitut. He's like one of like 4 white Canadians that ever did. And so, so it's like, and he passed. So it's a hugely meaningful thing for me to be able to do a project like this, and then to do it in wood, to do it in this material that's so appropriate to put on a boat and lift up and be able to do. And in this case, we'll get, I hope my team get to be involved in the actual construction. So we'll go up and participate as well. And that's the greatest sort of honor, to be able to get to touch the things that make that kind of difference, right? In these really personal ways. That's my home. That's Vancouver. If you've never been, come on up. Our mountains are incredible. our ocean's pretty sweet. And that little building right there is called the Dock Building, and it's an industrial building. So I have this thing, and I'm going to show you another project in a minute, which is that why is it that like quote unquote good architecture is always the buildings like museums and fancy universities, like, and not everyday stuff that everybody experiences daily. I'm going to show you a supermarket in a second. I believe that we should be really focused as architects on all these buildings that otherwise are forgotten about. And this is a works yard building to fix boats. And we really love it. It was dirt cheap. And it's really simple. It's plywood inside, but we fix boats in it. But I think obviously it helps to be sitting in that landscape. But what we believe in is the idea that good design doesn't cost money. It actually is the opposite. The tighter the budget, the harder it is, the more imaginative we get to be. And I think that ethos in architecture is really important. Not everybody can afford big splashy architecture. And actually, as an architect, it's more fun to, as we were talking about, to have constraints, limits in what you can do. And not having a budget for this meant we got really inventive and had a lot of fun and made something really simple. And I think for me, that resonates versus this, which is quite complicated. And so it's not that we only do those things. This is a campus in California. I'm going to go slide through a couple slides quickly. This is a long story, and I won't tell it fully, but this is in China, in Xi'an, China, for an art gallery. It's not going to get built because I withdrew from the project because I felt like this should be designed by a Chinese architect, not a Canadian architect. Because it's in the center for culture for China. I'm like, really, guys? Maybe I don't really feel so Chinese. But it would have been cool. A super weird jump here. Anybody know where Tajikistan is? Good trivia question. Former Soviet Republic, right on the border of Afghanistan. Incredible place. I've been working here, Kyrgyzstan, Afghanistan, Pakistan, India, now Nepal, and Bhutan. And I do that because I have this tradition of building in mountain cultures. These are some of the poorest communities I've ever been to and in the world, and very hard to get to. This is on the border of Afghanistan. And we do schools here, we do bridges here, we do health centers here, we do community planning. And I'm writing a book, which I don't have time to tell you about, but is the story of Western failure to understand sustainability, and it all comes from a lesson here. So maybe if you spot me and you want to hear that story later, I'll try to tell you because I'm super stoked about it. But what I love about it is this is the place that brings you back to remember how real people live in the world and how there's joy in their lives and there's opportunity for them, but there's a need to kind of work in partnership with communities to just support them getting that next step up in education and otherwise working on university here as well, all for the AgaCon Development Network. So this is a place where we stay grounded as a firm, and it's been really great. And it does come from my merging of my mountaineering life with my architecture life, but it's a place we're passionate about. And part of it is, in the very short version, during the Soviet era, they had free oil. They were on the border of Afghanistan. They were given free oil. They had the highest literacy rate that I know of, 96% literacy rate, higher than the United States. Men and women were equal. It's Muslim traditionally, but it's Sunni traditionally, but men and women were equal, so very secular. The Soviets did all that in that time. And I'm not advocating for the Soviets. They did a lot of bad things, but those were good things. But they did it because they were the last frontier before Afghanistan, and that was the battlefield for them. But what happened, and this is the quick version of it, of the book I'm writing, what happened was when you're given free food, when you're given free oil, you build big homes, you build them in the middle of your farm field because somebody's giving you food. And they basically built the Western version, what they're used to seeing us do. Use poor land use, build suburban style houses that are too big to heat. And when the fall of the Soviet Union happened and they lost all of that support, they couldn't heat their homes, they didn't have the oil, and they no longer had agricultural land. And they're in these deep valleys with no extra space. And so what we've been doing is building back, pulling the homes out of the agricultural areas. And when I look across the 50-meter wide, 150-foot wide river to Afghanistan, you could talk to people, although you don't. Although, they're lovely, it's just there's no conversation. And they are living in this way that you lived 1,000 years ago. They built their homes in the worst piece of land to protect every square inch of agricultural land. They put them side by side to save heat, just like you would cuddle together. And it was this big eye opener that what we've done is actually created this deep investment in oil and losing our sense of understanding where our food comes from. And they're living in this ancient way. And the answer has to be somewhere between the two. And so that's the book that's coming out called Parallel Paths. A couple more things and I'll get out of the way. It's in the museum under construction right now in British Columbia. It's the largest mass timber cultural building in North America and possibly the world. We're really excited about it. It's crazy big. This is the state it's in right now. But the wood is so pretty, so beautiful. And the scale, these photos don't do justice, but it's just massive wood spaces that are just beautiful. And I think what I feel is that, I used to always say this, I think I said it on my first TED Talk, is that I've never seen somebody walk into my building and hug a concrete column, but it happens all the time when you build a wood building. And I do it all the time. I'm always like, yeah, it feels good. But as an architect, I think that we often over design things. We spend a lot of energy making things like extra nice. And sometimes you just go back to like, just look at the wood, just let the wood do the work. It's so beautiful. Just make beautiful joinery, be really quiet. And the wood does the work. We all feel connected to natural materials, everybody. And so I've never had anybody come into a building and go, oh, I hate the wood. That doesn't happen typically, right? This is a city hall, totally different mass timber story that I don't have time for. But again, like you're getting a sense, hopefully, of the diversity of types of projects that can be built in these materials. Okay, I did this because I made that point earlier. I always wanted to design a strip mall, which is something you never hear an architect say, or sometimes you do, but not enough architects. And I did because like where 95% of people live their lives is going to strip malls to buy their groceries or whatever. And so we got approached actually by a forestry company on Vancouver Island. They said, we want to build some retail buildings and we want to build this grocery store and we've got a big pile of wood. What can we do? And so we're working on this and I cannot wait to have an all timber grocery store, which in North America would be special, but in Europe actually is not. Tesco, if you know who they are, have decided that they're only going to build in mass timber. Walmart just built all of their big offices in mass timber in Arkansas. There's a huge shift now where every major company in the world is starting to recognize that they have a civic duty and a belief of their own to build for climate, and there's this shift towards mass timber. This is in a fairly small northern community. It'll probably never have landscape quite as nice as that, given the climate, but it's a really sweet little grocery store, right? And I think there's an amazing chain of grocery stores in Austria that always inspired me, where each little town you drive into, it's the same chain, but in each case, they have a different architect and it's all wood. And each one is literally like the modern town church. It's like you go into small towns and the church is the center. And the architecture of these little grocery stores, where, let's face it, that's where people gather, has turned into that. And I think that is a really exciting idea to start seeing it here in North America. So there you go, that's that. All right, last couple slides. This is in Paris. I apologize that I can't spend time on each of these. And this is Ronald McDonald House, which is a home for 73 kids, families with cancer in Vancouver. Probably the most important project I ever did and the first CLT project ever built in North America. We finished it, I don't know, a little more than a decade ago. There you get to see the CLT panels up in the roof and the ceiling there. I actually wrote a children's book for this. That's kind of throughout the house, all the characters of the book. It's a really special house and it kind of works. And I could do a whole talk just about this house. But what's also really interesting and really sad at the same time is that this serves 73 families, and the need for kids to come to our hospital, if you're from a rural community, to come to the main children's hospital in Vancouver is so large that we're now doubling the size of this building, another 75 families. But in this case, the new home, this is the technology really quickly. That's not a very tall building, but it's masonry. So I wanted to show how you could build a brick exterior on a mass timber frame. So this shows how we tipped up the walls, the big mass timber panels, and we put light wood frame floor, what are called cassettes in between. And we did that and saved a ton of time and money as a result. But this is what I was going to jump to, and I think this is the last project just to touch on here. And this is one that we're just working on right now, and it's around the corner, just off the site of the Children's Hospital, but near the other house. And this is for longer term stays. They don't have a big lot, so we're building a tower. The architectural feel somehow in the same family. But our code is like your code now for size for earthquakes. And building this is a 14-story mass timber building. It's gotten a little harder with our brand new code edition. It's gotten harder to do that. And it's actually, I wouldn't say that. It's hard to do in all wood. And so we're doing this as an all wood project, meaning there's none of those steel braces in it, not a concrete core for the elevator. It's all wood with this really cool system that repairs itself in an earthquake, which is hard to explain, but I'll try to. And I'm excited about it because the most important thing is the families it serves. But the technology in this will teach, I think, a whole generation of how we can build it here in California, this size, if not bigger, buildings entirely in wood, which is really effective. Why this matters, and I'll end here, to build it in wood and in this kind of way. There's other variations. I don't want to say this is the only way. Is these buildings are built on what's called a rocking shear wall. So the panels basically allow the building in an earthquake to move, and there's little tiny, what are called fusible links. They're not tiny, they're actually like this big, but there's steel links between two panels, if you can imagine. So the building's rocking, the panels are doing this. Those little steel things yield, that means they bend. And as they do, they can basically, the building will snap back to place. It'll come back after the earthquake, and you take those out and replace them. So it's very easy to repair the building. What, unfortunately, we don't recognize in our building code anywhere, except for in the countries that have already had a big earthquake. Don't let this scare you. This is the scary part of the story, is that our building code here in California and Canada it says that in a big earthquake, you need to be able to get out of a building safely. Good, right? It doesn't say you have to be able to use the building afterwards. Now, there are lots of buildings that are post-disaster. I'm sure here on Stanford, that's like a higher standard, and you can build that way, but it's a higher standard. Not everybody can afford to do that. The building code doesn't require you to do that. And so what that means is all those big concrete towers after an earthquake become unusable by design. So one of the exercises my team have been working on for several years is an assessment of what happens if San Francisco or Vancouver gets a big one. It's not the risk of people being injured. Hopefully very few people are, or none are. It's really the fact that what do you do when all of a sudden 2 million people don't have a home overnight? That's the risk of the way we are currently building in concrete. Because concrete buildings, when they fail, they basically crack. That's okay in an earthquake. The steel, the rebar inside stretches, and you can't fix it. So those buildings become obsolete. These ideas are here so that we can actually create buildings that can keep our cities alive after big events. And we know not just earthquakes, we're going to have more hurricanes, more high wind storms. The impact of these forces of earthquakes are actually similar in hurricanes. And so as climate change accelerates, these ideas matter not just in high earthquake zones, but in other areas of the country and the world that have these larger weather events. And so these technologies are woven from a home for kids with cancer into something that actually has to transform every city on the earth, but we're not talking about it enough. And that's why I flew down here today. So with that, I think I'm done. Oh, folks, the human make objects. I'm gonna let this video play while we wrap here. This is a backcountry ski hut I'm building with a helicopter for 23 people above Whistler Blackcomb in the backcountry. So if you're a backcountry skier, come visit this in next year. We're gonna have it built next summer. Okay, it's done. Now what?
No, don't take off.
Oh, don't take it off.
No, you have to sit and answer questions.
Oh, I do.
Yeah.
Okay. Thank you for all of your patience with me. I am Canadian.
Oh.
Okay. Where's my water? Is my water? So there.
Yes, hi. Yeah.
Good.
Thank you. That was great. We're gonna just ask a couple questions. Give you your water first.
No, I have it's okay. I have a can somewhere.
Are you okay?
Yeah, I'm all right. I'll be
Maybe
okay.
a little water bottle.
It's not important.
Yeah. So earlier today, we were talking about how for most of this century, architects have really focused on a specific aesthetic style to achieve success and have their brand. And you're really much more focused on kind of being the wood guy, for lack of a better word, and really just achieving mastery of that specific material. And not, I mean, you hardly talked at all about the finished work and what it looks like. That's kind of irrelevant. It's more about the process of what can the wood do for me? How do I get there?
So this is going to sound terrible as an answer to that question. How things look is the easy part. And it should be seen as the easy part. Making pretty things is that, I don't think that's that hard. I mean, everybody has a different opinion on what's pretty, but it's not that hard. Giving things meaning is hard. That's the difference, the shift I think architecture has to make, is what does meaning mean, right? It's a meaning to the user. How does it transform their lives? Meaning to the climate, meaning to, how is a building actually creating meaning? And, you know, I believe all these things are stepping stones, right? They're all learning processes that then you share. And if that's growth, that's what we do, right? So our role in a way is using the buildings as a kind of teaching tool, right? A way to share. And I do, of course, I love the way they look. I can totally nerd out on architecture, and there's so many brilliant architects in the world that I adore. But the thing I love the most is when people bring meaning to what they do. And there's a million versions of what that looks like and perspectives, but it's like beauty is more than skin deep. Right?
Yeah. Yeah.
Kind of following up on that, you've talked about the idea of kind of quietness. And I'm really curious about selecting a single material, something like wood, which comes in specific shapes, and kind of using it in aggregate to start to give meaning, to give scale, to give texture. Is there a kind of rigor to that, or a methodology that you guys use within the office?
Enormously. So I think we were talking about the students. So the reality is we make things in rectangles. It's the most practical way to manufacture things. It's incredible just to get into the weeds of like how you move things on a truck. Interesting note, I built a building in Minneapolis. I can put 6 mass timber panels on a truck in Canada, but then I have to take one off because I can only drive 5 on a Department of Transportation road in Minnesota in the United States. And that's literally what we did. We moved panels and took one off and then moved them because it was the cheapest way to move them. So you get in the weeds of rigor when you understand not just the fact that, what's the most efficient way to cut this panel so that I don't have waste. How can I do this entire building with as few touches as possible? Every time a human or a machine touches it, that's cost. So how do I craft this thing with as few moves as possible? That's like rigor. And then how do I proportion everything so that there's just as little waste as possible? Right down to how do I truck it there and keep the cost down? Yeah, it's incredible the weeds you get into, but also that there's that's the birth of the aesthetic as well, right? It's like that creates the proportion and through all these practicalities. There's so much intention in it all, and it's been a wonderful learning process. Like it's taken us a long time. Who knew that Canadian roads are apparently a little stronger than American roads?
So we talked about some of the things that make your practice, your firm, a little bit different from a lot of others. And one of them is you're a maker, right? You like working with your hands, and you encourage your staff to learn by making. Can you talk a little bit about that and why that's so important to the practice?
Yeah, so when I was in architecture school, I was a professional climbing guide, and I was also a carpenter, and that's what I did before. I'd actually never had a real job as an architect until I finished school. And I think that was good because I needed that time to just spend time learning how to make things. And the weirdest part for me is I lived in New Haven, Connecticut at the time, and I ended up buying a house built in 1855. And I didn't have any money, so I had to fix everything. And houses of that era are really interesting. And I ended up basically having to learn how to be a good plumber, electrician, fixed all the structure, expand the building. I learned way more of owning that house than I did in architecture school, is the truth, because it's not a diss on architecture school. It's just a very different skill set. And it empowered my ability to be able to spend time with tradespeople who I love spending time with, because they let me swear as much as they do. But I really feel an affinity to people that work with their hands, and I, every chance I get, I try to build on my own. And then I feel, because I've been able to do that, I've been able to kind of really more intimately understand how things go together, how design works or doesn't work, why, where some of these gaps in communication happen between those that make and those that draw, and how to close those gaps, right? And so I mentioned that I think I mentioned, we talked about it. I have a school that's called Design Build Research, and I started it 10 years ago, and I don't have a lot of time, so I do these camps. And they're 2-week camps where I take 7 or 8 builders and 7 or 8 designers, and I put them together, and we have to build a socially impactful project in our place. So right now we're moved it to that island I mentioned. I used to do it in central British Columbia. And that process is basically what I think of as healing the divide, because there is a very different conversation between those that make and those that draw. And the more you make, the better you draw, and the more you understand why people design things, the better you build. And so it's not rocket science, but it's basically an incredibly enriching way to think about things. And I think that probably is why I talk about how things are made more than I talk about how things look, because I kind of just love that process, right? And I guess that's probably the roots of it. Yeah, I don't know. I mean, I think my grandfather was a historian, but he was a really good woodworker. My biological grandfather was a pretty well-known architect, and I feel more affinity to my woodworker architect or grandfather than my architect grandfather. Yeah.
One of the things that came up when we were talking with the students earlier was kind of all of these vectors that come out of this. You're teaching a school, you're helping to convince jurisdictional authorities, you're talking to trade associations, and we're, wondering somehow you have all of these subdivisions, within here, but it seems like it's more holistic and mission driven, and maybe I think it comes out in your talk, but maybe you could talk a little bit about purpose or meaning or the drive behind what you guys are doing.
Yeah. It's been a bit of a stumbling process of figuring it out. There's no roadmap to what we've done. There's been some really cool lessons that actually I kind of realize now that I know I might be able to do this again and create some other innovations and sell them, because it is actually a pretty low-hanging process. I'll explain that in a minute. But it does come back to purpose, right? So I went to Cornell and I went back and lectured there. And after my lecture, one of my old professors, who was probably like 85 now, he's like, "Are you really religious?" And I'm like, "No." He was so confused of why I wanted to do good by the planet. And I was like, "Well, you don't have to be religious to want to do good. That's not how it works. There's nothing wrong with that being your motivation, but that's not my motivation." But I was like, "Oh, that's so interesting that he couldn't understand why I wanted to." It's so simple. I have 2 children, and you don't put kids on earth without wanting them to have a better life than you had. And right now, the stuff I talk around climate is without question the existential issue for every human on earth, and every child on earth should be respected by us doing better individually. And I write something in every book I ever written. I always write at the beginning of it, it's every parent's job. This is what I believe. It's every parent's job to tell their kids they can change the world. But first, it's our job to show them that we tried. And I think that second part is too often missing. I go to big climate conferences all the time, and last year I was at the Aspen Ideas Climate Conference, and I was talking about this. There's 700 people at the conference, and I was the only person from the building community speaking. I was the only person possibly at the event from the building community, even though we're 47% in America, right? And it shows the disconnect. And Camilla Harris, the vice president, spoke in my session. And she got up, and she's lovely, nothing against her, but she got up and did the classic, "There's so many young people in the audience, you guys are going to solve the problem," right? How many generations are going to say that until it's too late, right? That's the problem. It's all of our responsibility. And it's this sort of sense that, as I got to take my kids on these adventures when they were little, I kind of was single parenting for a long time. And I took them all over the world, crazy places. My son and I kayaked the border of Afghanistan when he was 9. And it was the realization. I took him out to Antarctica and paddled for a month in Antarctica with him when he was 10. And it was the realization that the world he will see when his son is 10 is very different than the world he sees now. Glaciers are going. I climb mountains. I'm on glaciers all the time. They're going fast. We have 120 glaciers on Vancouver Island. It's expected in 10 years we'll have 10. So, architecture and any job you're at has a relationship back to that story, but you cannot be, I cannot be motivated by anything other than the fact that this is so existential. It has to be deeply rooted in the work I do and the message I share. And making one building at a time isn't going to solve the world. Finding technologies that will change every building, that will solve some of the problems of the world. And so I love making buildings. I like just being in my wood shop making a table. But the truth is the messaging is what's most important.
All right, I'm going to get a little bit lighter.
Oh, is that heavy? Sorry about that.
No, it's fine.
It's not going away.
You have a higher purpose to your work, and like that's what's so beautiful about it. The aesthetics still end up being great, but that's just the result of the pursuit. But I wanted you to tell a story. You told me earlier today about the sound impact, the benefit. So for those of you who don't know, the Escondido Village graduate residences project we did on campus, it's like 2,400 graduate beds. The main driver for that project was to disrupt the community as little as possible. So we chose a structural system that could be prefabricated off-site, brought and erected really, really quickly with limited noise, because we've got this community right here that we're trying to take care of, and we don't want to disrupt them. And you had a funny story about a similar project.
Yeah, I actually used this in the last TED Talk. So I have a really good friend, Andrew Waugh, who's deeply passionate about wood buildings. His practice is based in London, England, and he and I lecture a lot together all over the place, and he's been at it since as long as I have. And he was building this fairly small building in the heart of London recently. It just finished last year. And they put up the permit sign saying we're about to build this building. It's maybe like 4 stories tall. And it was right next door to this pretty famous music studio where a lot of famous music recording artists record. And the owners of the recording studio are like, you cannot build next to it. We won't be able to work here for the next 2 years. Like literally, you're going to end this famous studio, and the list of like famous musicians is huge. And so they turned around, Andrew and the owner said, listen, if we put up a little light out front, and if we promise to build the building for the same amount of, never going above the ambient noise, street noise of London, and if it goes above the street noise of London, the light goes off and we'll pay you some money. Would you allow us to move forward with this project? And so they did this. They put a little solar panel and this little light, and they never went above 36 decibels, which is the ambient noise. And so I love that story because you're going to hear endless numbers of contractors saying that's impossible. They built this beautiful building and won some of the top awards, the Rebo Award in Great Britain. They did it. It's totally possible. It's all possible. All this stuff's possible. It's only our tendency to resist change that's causing these challenges. Well, all of it's doable. We know the answer to climate change. It's not rocket science, but we have to do it.
Well, maybe along that line, on kind of a parallel story, and maybe kind of heading towards optimism. You were talking to computer science students versus architecture students. I was wondering if you could kind of relay that, and then kind of adding to that, one of our students asked you, like, do you feel hopeful?
Yeah,
and maybe kind of talk about that as well.
Yeah, great. So, I'll do the first part. So I told a story today. I got to speak in Barcelona with a great group of students from IAC, which is a great architecture program, and they have this cool lab, and they're 3D printing earth and making cool wood things. But I looked out at the students. There were about 300 of them at the time, and I realized that, and I said to them, I'm like, if I was sitting in a room with computer scientists, how many of you in the room would, if I said, how many of you in the room are going to sell a company for $10 million in the next 10 years? How many of you would raise your hand? And at least half of the computer science students would say that. And then I looked at the architects and I'm like, how many of you actually feel like you're going to sell a company for $10 million? There's not a single architect in the room who's going to say yes, right? If you know anything about the profession, but that's the problem, right? Because the largest material man makes on Earth are the building structures we talked about today. So what I believe is after mass timber, what's next has to be, I think, a plant-based solution that's from vascular plants from different parts of the world that allow us to use all organic solutions to build structures more in a 3D printed way. We actually produce about 27% of the structure as a complete waste because it comes in squares, rectilinears, and structure doesn't work that way. It looks more like tree branches. And so I think whoever figures that out, those kind of innovations, which I hope is architects, I hope is from the sustainability school. I think the sustainability school here, like where else but Stanford are you going to get these kind of ideas to come from? And the cross-pollination that this campus clearly works hard to create, of bringing biologists and physicists and architects and engineers all together. The idea that a whole new structure that none of us have ever imagined is out there is very much in our reach. But no one in the world is talking about it. So one of my missions, my best friend and my climbing partner is a venture capitalist with a partner at Andreessen Horowitz here. And I'm like investing in anything other than this is a small time investment. If you solve this, you make Elon Musk look like a chump change. Because like there's nothing on earth we make more than structure. And there's nothing on earth that'll make a bigger dent in climate than solving this problem. And so that group of 300 students in Barcelona and every student in the Sustainability Center should be thinking about how I can make $10 million off my idea and sell it to somebody, or build the world's biggest company that actually solves this existential issue. And that is why I have hope, right? There's a lot of reason I have hope. The other reason is what I was explaining, is that I think of my work and I think about life a lot, about Darwin and what he taught us about evolution, right? So all species on Earth, flora and fauna, are there to use as little energy as possible to propagate and survive. That's kind of evolution, right? Except for humans, who use the most amount of energy possible to guarantee we don't propagate and survive, right? But we are nature. And so I do believe there is hope for us to solve problems, get out of our heads and back into our hearts and figure out how we do it. But I think these programs, especially these cross-disciplinary programs, are where all the answers are going to be. And I love the idea of 150 architects sitting in the room making 10 million bucks each off their ideas. But I want the architecture community to remember that's where we came from. Those are our roots. We used to own the material library. We used to invent the materials. We've given that away and we've become catalog shoppers, where we flip through a book of somebody else's products and figure out how to make a building. We have to return to that sense of invention, because that's the creativity that we have been taught, and the creativity that I think each of us choose this profession, because it's not a high-paying profession, but it's a profession of love, right? So that's my sense of hope.
We ended with optimism. That's all I really want. So one more round of applause for Michael, please.
Thanks, Todd. Thank you.